Okay, so all right, everyone. I'm a little bit nervous for today because whilst I've had business glossary sessions with the business, it's been a lot more formal and it's a lot easier to go through. Well, in a way, it's a lot easier to go through, but going through a whole Excel spreadsheet of all the terms can be rather boring. But when you've got to sign them off in some form of approval meeting, then these are the things that you have to do. So the reason I've done the ABCDEFGs of data science, and I don't know how many of you read my post, but and Veronica will remember this as well. It was almost 10 years ago, Veronica, 12 years ago, when we had two twins approach us to work for us. They were from Limpopo or Mpumalanga, and one of the guys, he really impressed me, and what he shared with me was that he would come home from school every day and swat the dictionary, those blue books on the dictionary, and his English was fantastic, and the ability to communicate with him was really impressive. Now, we do have people in South Africa that have not had good education, and then communicating and talking to them is pretty difficult. But this man had spent many years studying the dictionary, and you could notice it immediately when you spoke to him. You could notice his understanding and his grasp of the language. Veronica, do you remember David and Vincent? Vincent was the other twin brother. He didn't spend much time in the dictionary, and we had some challenges communicating with Vincent. But this was really impressive to me. And when I was thinking of a topic, because one of the guys couldn't make it, and I saw this post on 130 plus terms, I thought, sure, this is a very impressive way to start our understanding of data science and statistics. So I've also invited Don to help me. I think the statistical terms take another level of complexity, and so wherever there's a need, I'll actually ask Don to maybe give us an example of where he's used this statistical method in his econ data to give us some examples. But I'll certainly show you what I can get from Bing and what I get from Statistics by Jim. So Don, thank you for joining us. I really appreciate it. And hopefully wherever we need a statistical explanation, Don will be able to provide that for us. So please, guys, love it if you do interact or if you ask questions. So what we're going to do is I'm going to show you some of the terminology that I've collected. Of course, I've done this in Power BI, and you can view it on the web. So I have all the terms. I've done this with several business glossaries, okay? And just to give acknowledgement, this was the lady that did the blog post on 130 terms. I've got credit to Don, who's here, and Modelware. And then this is a website that I found called Statistics by Jim. And wherever I can, I'll link the statistical term for an explanation from Jim. And we'll show you how that works. Okay, so this is an example of the Power BI. Nice to see the different terminology. So S has got the most terms, 44 from statistical. So there's a lot more statistics terms. And Don, I don't know if you remember when we first met, I remember talking to Rousseau, and he was rather disturbed by the fact that everyone was raving about AI and machine learning, and Rousseau was saying, but we're doing it. All of what you're talking about, we're doing in statistics. And Don, I don't know if you have anything to share about that, but I think you come from a very strong background with a fundamental understanding of statistics when you go into the machine learning environment.
Exactly. So what's been interesting as someone that studied statistics at university, as my main as the main thing I focused on, is that it's the ideas from data science and the advances in AI all come from techniques that were developed decades ago, and it's just that the increase in computation have made it possible to use these techniques. So I don't know if you've seen those Venn diagrams of what distinguishing between what computer science, statistics, and data science is, and it's just that the three circles that where they overlap, where three circles overlap, that's data science, and data science is where statistics, computer science, and then domain expertise overlap. And that's why data science is now becoming relevant to all sorts of specific disciplines. It's becoming very relevant in finance and economics and banking. It's becoming really commonly used in biology and psychology. So all sorts of domains are now using techniques that come from statistics that have been made possible by because of the increase in computing power that we've seen over the recent decade or so.
Yeah, that was certainly for me. It was when Rousseau challenged me to say, what is this all about? What's wrong with what we've been doing it all the time? I had to take a step back and say, well, what is the difference? Now, what I have, if you look at some of these terminology, actually, the things that have come about, you'll find that there's a lot of almost data management terms. For example, accuracy. Okay. There's a term in data science that was not in statistics, and I'm not saying it doesn't exist, but there's accuracy, AI ops. So there's sort of things around it, but the fundamental model development is based on statistics. Okay, so this is a Power BI. You guys can, I'll provide copies that you can make use of. And basically what I've done is one can click on any of these terms and it will show you where the definition refers to it. So there's predictive analytics, using data and statistical algorithms and machine learning techniques to identify the likelihood of future outcomes. Now, what I've done on here as well is just to help us, and I liked what Don said about how easy it is to look up. And I just wanted to share with you as an example of, here is a link that I provide to Bing, and I ask Bing for some examples, and these are the examples that Bing has provided me. Okay, now of course, if you come into this, and if you go into Copilot, I use this a lot. I've been amazed and saying, please explain predictive analytics in simple terms. Okay. And there we go. He's busy doing it all, and he's giving you references and different things that you want. So actually starting here is really nice, and then you can jump around all over the place to pick up more details as to what that may be. Okay, and then it's nicely integrated. So if I jump backwards and forwards, I'll be able to see a search engine for that. So I'm certainly using Bing a lot more. Almost about 8 months ago, I'd never used it, maybe just for some images, and now I'm using it quite extensively. And of course, there's BART as well, and that's also, you can also make use of that. I'm just finding Bing a lot easier to drive from Power BI, so that's why I'm using it. No other reason. Okay, so there you can see the different definitions, but I can also then, for example, talk about a forecast in the search. There's forecast, and I can pick up none of the terms over there. So that wasn't very good. Or analytics. And there's my different analytics that I've got. And then I can go to jump over to statistics by Jim. Now, sometimes he doesn't have it because it's not really a statistical term. Okay, and sometimes he does have it. So I don't always find a combination in statistics by Jim. I think he's focusing more on the use of the terminology. So let's try a more statistical. There's a binomial distribution, and when we go over there, sorry, that's the wrong one. If we go to binomial distribution and click on that, we can see statistics by Jim, and he can give the different uses, and he gives nice examples. So again, I'm hoping you can see that there's actually a nice interactive way that you can use to navigate through all of this terminology. So it's trying to make that business glossary of ours a little bit more practical and interactive, as we said. Okay, so in this Power BI, I've got all of the different terms. There's A/B testing, and then I've got Bing examples. So when I click on any of this, for example, accuracy, there's the different level of accuracy and A/B testing, and that goes and finds different links within Bing. I don't know if you are finding this helpful, but there's a way to navigate and understand all the different terminology. Maybe I can just pause here. Is anyone any questions? Is there anything you'd like to ask before we go too far? No questions? Okay, so for example, there's a term called base rate fallacy, and maybe I can ask Don to explain that, or Don, if there's an example that you can give by a base rate fallacy. Is that something that you have used?
So not specifically, although my understanding of that is that it's all about what information you use to assess whether something is statistically significant. So if you and so the reason statistics matters, and having at least a basic understanding of that, if you are going to be using statistical tools, is that if you're not careful in the type of data that you use to test, then you are likely to get incorrect inference. So you're going to get the wrong answers when you test certain questions. So you need to understand that the way that you set up a question that you're trying to answer affects the way that the type of data that you need to use to assess whether the question you're looking into makes sense. So base rate fallacies are all about the fact that you can get seemingly correct answers when you're using the wrong data to test the question you're interested in.
And I liked what you just said there, Don. These were some of the ones that I'm looking at, is affirming the antecedent and the consequent. And it's about that logic that we use to infer, and we make mistakes. So if you look at this one, was quite a nice example. If I'm a student at Wake Forest, then I'm in college. And so here are just some examples of how we get things wrong. And I like this example it's called helpfulprofessor.com. And he talks about Alex and Imran are work colleagues. They both know that if they do well in a project, then they will get a raise. The next Monday, Imran walks up to Alex and excitedly tells him that they both got a raise. Alex is overjoyed and slaps Imran on the back, saying, "We must have aced that project then." Okay, so he's making an assumption that the raise was due to acing the project, but that's not the information that Imran gave. And so there's this fallacy that we get involved with, and of course we can make some bad examples and make some bad conclusions. So this is the definition. Structure of affirming the consequent of a syllogism. Syllogism. So premise 1, if X, then Y. Premise 2, Y, therefore X. So we're trying to come back from Y to X, and that's where our fallacy is being introduced. And notice that they're saying that there's the valid one to say, if you have a premise, if X, then Y, and you have X, then the conclusion is Y. Now that's a valid deduction or inference that you've been able to create. Now this one is an invalid one. And the question we need as people that are data governance people or data management people, we need to understand the logic that's being used and we need to be able to check for these type of fallacies coming into the analysis. And we need to be able to say, well, how did you get there? What was the logic that you used? And maybe I can pause there, Don. Is there something that you can comment or share in this area?
Not specifically, but it is not specifically in practice, but I think in terms of the underlying idea is that for many types of problems that you will deal with in data science, or if you're in statistics, you will have a certain amount of information, and then but you'll have already. And if you have that information, you want to use it to in the question that you're trying to answer. And so it's not that you don't have truly independent information. So you need to understand that if you're going to use that information, you need to use it in a specific way to make sure that you're going to get representative answers. And so the same kind of idea will, I think, will be relevant to some of the things we'll talk about later. Just that you need to, it's called conditioning on information. So you need to use the information that you have appropriately when asking questions. And so this also matters in metadata when
Right.
you, this will matter for how you label information. You need to understand what the embedded relationship between different bits of information might be, because that is relevant to the user. If they don't understand the relationships between different data, then they could draw the wrong inference, use the data incorrectly in models. So
Okay.
There's a golden thread that runs through the concept, then the data management approach, and then the actual application when you're trying to do analysis.
Okay. Fantastic. So that conditioning that you refer to, is that the same as this, what we're referring to here as this conditional probability?
In some sense, yes. So conditional probability is if you know something. So if you know how many black and white balls are in a bucket, and you have pulled out a black ball, then the probability the probability of pulling out another black ball is conditioned on the fact that you've got a black ball in your hand. So
And that's with and without replacement. So
it depends. The exact definition depends on the specific question that you're interested in. But conditional probability is all about again, the information that you have, and then the specifics of the question that you're interested in.
Okay. Great. Okay, so that's sort of, if I look now, I just want to go through my slides. All right, so these are the different terms that we have, and you can look at all the different ones. What I've then done is broken them up into the A's, and then look at all the B's, and we can pick up here things like bias from statistics. And so there's a term that's defined by data science, and data science is an error in the model that causes it to consistently predict values away from the true value. And then the statistical definition is a measurement process or estimator is said to be biased if, on average, it gives an answer that differs from the truth. Okay, the bias is the average expected difference between the measurement and the truth, which is quite interesting. So I was really fascinated by this as that extra level of detail that statistics was giving me compared to the simple definition in data science in terms of an error. Okay. So
perhaps just an example, if I can cut in there, Howard.
Sure.
Often forecasting models are sometimes biased. So sometimes a model might give you consistently optimistic projections.
Right.
And so one good standard model check is to check whether the forecasts are systematically biased in one direction. And you can, again, in a data management or analytical context, you may want to run these automatic checks to see when a framework or humans are being systematically optimistic. And the nice thing about bias is that it's a commonly used statistical concept, and so you can report this as a standard concept all the time.
Okay, so in that example you used, when you talk about overly optimistic, that bias, I'm assuming, is positive, and a negative would be, and then you'd be able to validate that distance, or the average bias that you're picking up, which is a nice mathematical term. Now, Don, this is something that we discussed, where you, when you use these type of models, you would not run one model, but many models to be able to see which one is more appropriate. And I'm assuming you'd actually check the quality of those different models using something like this. Is that sort of what you were doing?
Exactly. So I think in a context where you're interested in projection, it's really useful to have different frameworks compete with each other all the time, so that you
Right.
can see which ones are more accurate. So it goes to your accuracy definition earlier, and which ones. So some might be accurate at the moment, but they might not be accurate, have been accurate all the time. So you want to be able to monitor recent performance of different frameworks and their performance over long periods of time. And that helps you get a feel for which models to place more emphasis on when you are trying to get an answer or trying to explain something to someone. If, for example, a projection is systematically biased upwards, then there's over optimism. So if it's economic growth that you're projecting, if you're systematically biased upwards, then the model is more optimistic than it should be. And then if you are getting a forecast for a specific quarter, you must worry. It's important to then worry that it might be an overestimation of where economic growth might go. So these are things that are important in data management as well, because if it's something that you're going to want to look at regularly, it makes sense to automate that and to have these concepts set up in your system so that they are recorded over time, so that you can track them as concepts as well, with their definitions being recorded in the metadata of your system.
Right. And Don, do you have an example of when you use something like GDP forecasting and nowcasting? Do you have an example of where you guys record the bias, where you display the bias? Is there something you can show us that will demonstrate this? Sorry,
Yes,
I'm putting you on the spot.
I don't have something at hand, but for bias, it is something that we have as a standard test for a model. But you can also just plot forecasts relative to the concept that the actual historical value of a concept,
Yes.
and you can visually see if there's bias. So bias has a statistical definition, but you can see if the forecast is systematically above the outcome of the variable that you're interested in, that your forecast is going to be biased. So there are both visual and formal statistical checks of these concepts. And so it's good practice whenever you do analytics, particularly predictive analytics, to just present plots as well. So yeah, I hope that answers your question.
Is that sort of what you're explaining in terms of backcasting, where you actually take the model and you backcast and you compare it to what actually happened, and then you'll be able to see whether it's overly optimistic compared to the actuals?
Backcasting typically has a slightly different definition. In a economics or finance context, typically what it means is using the data, rerunning your models backwards through time to check that, using the data that you would have had at hand at a specific point in time, and then doing a projection. The reason you do this is because economic data is revised. And so you might have had, now that data has been revised, now you've got actually a different vintage of the data for the concept that you're interested in than you would have had if you were actually using the model in practice. And so a common mistake people make, particularly with machine learning, is they use final vintage data. So the data that they have today, and then they use the historical final vintage data to build their models. instead of using the data that they would have had at that time.
Right.
And we
Okay.
find in economics that they give you typically completely different forecast performances, and you often build you parameterize your models incorrectly if you do that. So we can go into a lot of detail on that, but that's basically what it means.
Okay, thank you very much. Okay, great. So these are the different terms, and there you can see C, D, all the different terms coming out there. Ecological correlation, some quite interesting ones. The correlation between averages of groups of individuals instead of individuals. Ecological correlation can be misleading about the association of the individuals. That's based on some of that fallacy that we refer to. And these are the different these are all the different terms that you can go on. And if you'd like, you can make use of this, and as you go through the term, you can understand what needs to be done. All right. So what I wanted to show you right at the end was something that, Don, I don't know if you would like to give in any other examples of some of that terminology. I wanted to just do this, what we call this flashcard. There's a way of learning this terminology. But is there something you'd like to share before we go to that?
No.
Okay. All right. So this is a program that I used, and this is called Quizlet. And what you'll see if you look at my library has all these different study sets. So there's all the ABCD of metadata management. Okay, now this was done in DMBOK version 1, and at that point in time, they had a hyphen between meta and data, calling it metadata management. And there's one in data architecture, and you can see here are all the terms that we've built: data warehousing, reference data, master data, data governance, data security, data quality. So if you need terminology, and we always shout at our business people that they need to define their terminology, but a lot of the times our terminology is not well defined. And it's helpful to have something like this that you can go through. And I really like this example of some of the terminology. Here you can see the difference between the different types of abstraction. So abstraction or horizontal abstraction, and that is the process of partitioning a model into smaller subparts for presentation used in data modeling. And then we've got vertical abstraction and accumulator snapshots. So there's just some examples of how you go about it. Okay, now that's in the ones that we know. Now I want to show you what we've done in data science. And so here's a way of learning, and I'm actually going to, hopefully you guys will join and we'll get some, this is the game that we can make use of, and we're going to have random teams. So if you can, on your phone, it's a lot easier on your phone. So we're going to have term and definition, A/B testing. Okay, so this is just an example. Okay, so if you guys wouldn't mind joining that quiz, if you can join it on your phone, it's a lot easier. I tried to do it on my laptop, and it didn't really work. So if you just take the URL. Just waiting for 4 or more players. Okay, so they're not Nick. Not Nick. Nice. No, Don and Mr. Mark, you got it. Okay, Veronica. Right, let's see how Veronica's normally the champ at these games, so we're going to test her today. Okay, let's get going. Nice to see everybody joining. Just a couple more seconds, and let's do it. Okay, I'm going to assign random teams. So that means so we'll have the giraffes. There's Veronica. and the tigers is Don, and not Nick and Mo, and then the lions. Okay, so now if we start the game, okay, let's see. Assessing the contribution of each feature to the models. So you just have to answer there, okay? So okay. So I just wanted to show you, I'm sure you guys have got an understanding of how that works, but quite a nice way to be able to review your terminology, especially your understanding of the different business terminology. And the next one that I wanted to do was, as you can see here, you can use these flashcards. So affirming the consequent, and let me go to full screen. The definition of that, it's a logical fallacy that argues from premise A to B and the premise B that therefore A is true. So that's what we were talking about, is if you have that and then you go the wrong way around. Okay, and there's AI ops, and that gives you application of machine learning to automate and enhance operations. All right. So this is a way of going, what is an algorithm? A step-by-step set of instructions or rules followed by a computer to solve a problem. Nothing special about that, or perform a task. An alternative hypothesis. This one is also quite tricky. So this is in hypothesis testing. This is this null hypothesis. And I wanted to just maybe pause here for Don to explain what this is all about. This idea of a null, which it's almost like a placebo effect. Don, is there any, would you mind explaining that to us?
Yes, so you're typically interested in testing whether something is true or false. And so the most, a good example would be whether someone's left-handed or right-handed. Now, you have information from data about the distribution of the population, what proportion of people are left-handed or right-handed, and you can set up a test where you ask whether someone is likely to be left-handed. So you can say the null hypothesis, someone is left-handed, and then you know that the alternative hypothesis, because there's just two possibilities, is that someone's right-handed. So if you accept the null, it means that someone's left-handed, that the statistics show that someone's left-handed, or if you reject the null, then it implies that the test shows that someone's right-handed. The definition of the null versus the alternative will depend on the types of questions that you're asking. If there are just if there's just two answers, or if it is more complicated. Typically, these hypothesis tests are used to assess whether a result that you get is statistically significant. So you don't know if your forecast, for example, is accurate or not. And so a good way to test whether something is accurate or correct, but more importantly, correct or not, is to use a hypothesis test of some type. So it's something that will change depending on the question you're interested in.
All right, thanks, Don. And then to share with you the other ways of doing it, I don't know if you remember, this was a way of matching terminology. Okay, so you can have something called selection bias. You click on that one, and then you need to find out which one is true. So who can tell me which example talks to selection bias? So, for example, if you chose that one, then you get that wrong. Anyone know what selection bias is?
The first one, Howard? No?
This
hypothesis?
one over here.
Yeah. Nope.
Nope. Don?
What about the one to the right? Systematic tendency.
This one here. There you go. Okay. Nice. Okay. False discovery rate. Okay. And false discovery rate. So balance. Sure. These ones are quite hard.
The bottom right-hand corner.
There we go. Well done. Okay. Quantitative variable. So we have this one. So that one will be numeric values, right? Okay. And then we have rejection region. Anyone can tell me what the rejection region means? It's the one you can see the term, right? Okay. So really nice to be able to work through those ones. And then you've got another one called learn. This is a different approach. And it will ask you a question, and then you have to understand, or you have to choose the answer. Okay, a logical argument that concludes at premise A, and therefore, so that's not the, it's affirming the consequent. No, that one. Okay, wrong way around. Okay, all right. And then there's one more approach, which is the test, and I think that's okay. There you can go true or false and start the test. Set up your test, and then we can say 20, answer with term or answer with definition. Okay. And then we say the treatment group, select the correct definition. Okay. And simply enough, we can find that one, and there we go. All right. So any questions? I hope you found that helpful. I hope you found it's a way of helping your people understand the glossary of terms in a not so simple or complex situation. Any comments, Don? Anything from your side?
Anything from me.
Thanks, Don. Di, any comments from you?
I enjoyed that very much, Howard. Way back in 1968, I attended the University of the Witwatersrand and studied mathematics and statistics with Professor Blexley and Professor Kerridge. So
Yes.
a very long time ago. And we used to have this little machine called a facet machine. Don, you probably might have seen a picture of one. You turned the handle so many times to add numbers together. That was our calculator. So this has been, I'm really excited about this stuff and the way you've presented it, Howard. Thank you very much. And thank you, Don. It was lovely to meet a statistician.
I hope I got all the definitions right.
Yeah, it's a bit
also
nerve-wracking. Like
it
you
is,
could get them badly wrong.
It's very humbling to realize where gaps in your knowledge might be, and but that's why I think these tools are so interesting, because you really have all of this information at your fingertips, and the important thing is learning how to use it.
Great, thanks. And of course you can see here these are all the terms for data architecture, data management. Maybe we can get that was interesting, the terminology called abort to terminate a processing activity. That's quite abstract. Okay, and there's the term less specific in representation or without relationship to a specific instance. Okay, so if you'd like access to the set of terminology, this is basically, I'm not sure if you're aware, but there's a Damer Dictionary 2009, and I've basically pulled all the terms out and added them to all these different sets. So if you're ever looking for a term, and you'd want to understand what it's all about, there you go. So that's Basel, banking supervision. What is a business data steward? There's the definition over there. Okay, so let me see if there's anybody else, any other comments. Nothing. Mark, anything from your side? How did you find it?
I need to learn more. I like this approach though, and I did actually see some data science flashcards a couple of years ago. So there's a few of these things floating around out there.
Right. And that's an interesting comment by Jacques, who says flashcards can be effective when you want to memorize something. Now, that's certainly the case, but what we'll find as well is that when we're trying to review a set of terms, especially your business glossary, finding a more friendly or interactive way of reviewing these with your business data stewards is very helpful. Okay. And then, of course, where anyone can go and say, oh, shucks, I'm not sure what this term is, they can go and look it up and make sure that they understand the different aspects to the terminology. Now, I saw a hand go up and it went down. I'm not sure.
It was Kimberly.
Kimberly. Yes, Kimberly.
Good afternoon, everybody. My name is Kimberly. So I just wanted to introduce myself firstly because this is my first time attending this. And I'm interested in kind of shifting my career towards learning more about data science and actually getting into the data science space in terms of work. So I just wanted to thank you guys for giving me an introduction, although I was a bit lost with some of the terms, but yeah, I'm hoping that if I continue to learn and attend more of these sessions, I can get some knowledge and also get to meet people that are also in this space and learn more from them. Thank you.
Fantastic. Thank you, Kimberly.
Yeah.
Thank you so much for joining and sharing. I really appreciate that. And yeah, getting those terms correct is very important. I remember John O'Gorman commenting on one of my LinkedIn posts, and his comment was, Howard, you use so many abbreviations, I don't know what you're talking about half of the time, which is very valid. You know, we use terms as well that we don't always explain, and that's always something that John is very good at, is whenever someone makes a comment is saying, well, what do you actually, can we confirm your understanding? And is this the same understanding that we have? So I do think it's a very powerful technique of resolving conflict and resolving misunderstanding is when we go and make sure we know what they're talking about. Now, what I think is also very helpful is when we can start building a ontology or a graph relationship between these terms, and we can then start to navigate from one term to another. So that's something that is also very important, that we understand how these terms relate to each other. Antonyms and synonyms and homonyms, all those different types of things. It's helpful for us to understand. Okay. Any other comments, any questions? And if not, I think that I'll say farewell, unless there be someone who would like to ask a question.
Thanks, Howard. Thanks, Dan. Thanks, gang.
Thanks, everybody. Thanks very much. All right. Cheers, guys.
Bye-bye.
Bye.
Thanks, everyone.
Hi.
Bye.
Hello.
Bye.
Cheers,
Bye.
cheers, Kimberly.